Have you ever wondered how your favorite websites manage to store and retrieve thousands or even millions of user information so quickly and efficiently? The answer lies in databases. Imagine the vast amount of data that social media sites have to handle. Every post, every comment, every like, they all form part of a colossal data set that needs to be stored, managed, and made accessible at a moment's notice. Or consider an e-commerce platform, where millions of products and transactions need to be tracked and updated in real time. And let's not forget about the critical role of databases in healthcare systems, where they keep track of countless medical records, ensuring that doctors have instant access to crucial patient information. Databases are the unsung heroes of our digital world, silently and efficiently managing and organizing the tsunami of data that our modern lives generate. Without databases, managing and accessing such vast amounts of data would be nearly impossible. Let's start with the most common type of database, the relational database. These databases, often abbreviated as RDBMs, operate on a tabular structure, organizing data into tables that consist of rows and columns. Each row represents a unique record, and each column represents a specific field within that record. Now, when it comes to defining and manipulating this data, the Structured Query Language, or SQL, comes into play. SQL is the standard language for relational database management systems, allowing users to create, modify, and extract data. When we talk about examples of relational databases, names like MySQL, PostgreSQL, Oracle Database, and Microsoft SQL Server might ring a bell. These are all widely used relational databases, known for their robustness and versatility in handling structured data. Relational databases are widely used due to their efficiency and flexibility in managing structured data. They have stood the test of time and continue to be a reliable choice for many applications. Moving on to NoSQL databases, a more flexible and scalable approach to data storage. Unlike traditional relational databases, NoSQL databases aren't constrained by rigid schemas. This means they can handle a diverse range of data types, making them ideal for unstructured and semi-structured data. Whether it's a blog post, a tweet, or a satellite image, NoSQL databases can store it all. There are various types of NoSQL databases, each with unique strengths. Document-oriented databases like MongoDB store data in a format similar to JSON, making them perfect for handling complex data structures. Key-value stores like Redis, on the other hand, are incredibly fast and ideal for storing simple pairs of keys and values. Column family stores and graph databases, such as Apache Cassandra and Neo4j respectively, offer their own unique advantages for specific use cases. NoSQL databases are gaining popularity for their ability to handle large-scale data and their flexibility. Now let's delve into other types of databases, each unique in their functionality and structure. Starting with object-oriented databases, or ODBMs, these are designed to play nice with object-oriented programming languages. They store objects, which are neat packages of data, and the operations that can be performed on that data. Examples of ODBMs include DB4O and ObjectDB. Next up, we have graph databases. These are optimized for storing and querying data with complex relationships. They use graph structures with nodes, edges, and properties to represent and store data. Neo4j, Amazon Neptune, and Microsoft Azure Cosmos DB are all examples of graph databases. Then there are in-memory databases. These databases store data in the system's main memory, or RAM, instead of on disk, which makes for much faster data retrieval. Examples of in-memory databases include Redis, SAP HANA, and Memcached. Moving on to distributed databases. These store data across multiple servers or locations, providing high availability and scalability. Google Cloud Spanner, Apache Cassandra, and Amazon DynamoDB are all examples of distributed databases. Next, we have time series databases. These are optimized for handling time-stamped data, such as data generated by IoT devices or financial transactions. InfluxDB and OpenTSDB are examples of time series databases. Lastly, let's talk about spatial databases. These are designed to store and query spatial or geographic data, supporting efficient handling of spatial objects. PostGIS, which is an extension for PostgreSQL, and Oracle Spatial are examples of spatial databases. Each of these databases has a unique structure and functionality. They cater to specific needs and requirements, making them essential tools in certain areas. From handling complex relationships in data, to storing and retrieving data at lightning speed, to managing data across multiple locations, These databases offer a range of solutions for diverse data management needs. These databases cater to specific needs and requirements, making them essential tools in certain areas. So, how do you choose the right database for your needs? It's a question that doesn't have a one-size-fits-all answer. The choice hinges on several key factors. The nature of your data is fundamental. Are you dealing with structured data that fits neatly into tables? Or is your data unstructured or semi-structured? If it's the latter, a NoSQL database might be your best bet. Next, consider your scalability needs. If your application is expected to handle a large volume of data that grows over time, a distributed database could be the way to go. On the other hand, if speed is of the essence and you're dealing with real-time data processing, an in-memory database might serve you well. Lastly, think about the types of queries you'll be running. For complex relationships, a graph database could be just what you need. Choosing the right database can make a significant difference in the speed, efficiency, and scalability of your application. Let's quickly recap what we've learned about databases today. A database is a structured collection of data. It's like a digital filing cabinet, storing and organizing information for easy access, management, and updates. We've delved into the various types of databases, starting with the relational databases. They're like a well-organized spreadsheet, with data neatly tucked away in rows and columns, and SQL as the go-to language for defining and manipulating the data. MySQL, PostgreSQL, Oracle Database, and Microsoft SQL Server are some examples of this. Next up were NoSQL databases, the flexible and scalable solution for handling unstructured and semi-structured data. We touched on MongoDB, Redis, Apache Cassandra, and Neo4j, showing the diversity within this category. Then we explored object-oriented databases, designed to dance well with object-oriented programming languages, encapsulating data and operations into neat little objects. DB4o and ObjectDB are examples of this type. We also looked at graph databases, the masters of managing complex relationships. They use graph structures with nodes, edges, and properties to represent and store data. Neo4j, Amazon Neptune, and Microsoft Azure Cosmos DB are some examples. In-memory databases gotta mention too. They're the speed demons, storing data in the system's main memory for faster retrieval. Redis, SAP HANA, and Memcached represent this kind. We then discussed distributed databases, the ones that spread their data across multiple servers or locations for high availability and scalability. Google Cloud Spanner, Apache Cassandra, and Amazon DynamoDB are examples of this. Next, we delved into time series databases, optimized for handling time-stamped data. InfluxDB and OpenTSDB are some examples of this type. Finally, we covered spatial databases, the geodata specialists. PostGIS and Oracle Spatial are examples of this type. Remember, the choice of a particular type of database hinges on your specific application requirements, such as data nature, scalability needs, and supported queries types. Understanding databases and their types is crucial in our data-driven world, whether you're a database administrator, a developer, or just someone interested in how data is managed and accessed.